Welcome Math 30-2. Lamentably, I'm not here to be with you in person, and no, it's not Fishtopia, but this is the best I can do in terms of supplying for you a lesson on our rational expressions. Okay, please open your books. Hopefully you can see the fact that I'm on page 439. I'm not going to go and start at page 439 but the next one, because this is just something you would have seen way back in grade 9 about how much of the rules of adding and subtracting fractions, justifying it with counting up the different bases. I don't need that particular background for this particular lesson, okay? It just tries to give you a context by which you need to have, in comparison, same denominators in order to add or subtract fractions. This is actually the harder lesson, I think. Maybe I should have done multiplication, I don't know. But let's go ahead with adding and subtracting rational expressions, namely fractions. I'm going to start on the next page. Thankfully, we're going to start with easy numbers. Yay! Hopefully that's not too close in. Oh, okay. So we're going to begin with class example 1 on page 440 there. Okay. So because we have the same denominator right here, 9 and 9, those shall be comparably the quantity which we're comparing out of the numerators here. Okay? Because of the same denominator, we can go 5 minus 2, which will be 3. Because these things are in fact values of multiples of each other, we can reduce the fraction as well into 1/3. Sliding across, sliding across, sliding across. Oh no. Some people may think we can just do this. 8 and 4. Therefore, 1/2. But if we were to check our calculator to see, because we knew what 1/2 was, our calculator would reveal something otherwise. Just as a point of order, 2 over 3 plus 2 over 5, we can clearly see the answer isn't exactly, although we can't see on that big screen, 2/3 plus 2/5 isn't exactly 4 out of 8 or 0.5. In fact, it's 1.06 repeating. So we got to do something a little bit different than just simply add numbers across, because we didn't add the 9s across either. I'm just going to erase that because that's a common mistake that we think we can actually just simply add numbers across. What we need to do is set up the values in the same denominator. So what the best choice is to figure out the lowest common denominator or multiple. Uh-oh, my graphics card's getting tired. Whoops, denominator. Between the values of 3 and 5. Namely, the number which they both go into. A guaranteed way to figure out what number does 3 and 5 go into, it's what's 3 times 5, is a shortcut in terms of what is 3 times 5. Well, they both go into the value of 15. So, what we're going to do is we're going to make equivalent fractions. That's why we did in lesson 2 about making equivalent fractions. We're going to make a 2/3 into a 15. How do we achieve that? We're going to multiply that one by 5, because 3 times 5 will make 15. 2 times 5 will give us 10 out of 15. The 2/5 to make into 15, I got to multiply this by 3 times 3, make 15. Whoops, sorry. My brain is getting tired at this point. Times 3, that would be 6. So what we have is actually the fractions in the same comparison as 10 over 15 plus 6 over 15, which gives us 16 over 15, which makes more sense as to why does a calculator show up as a 1.06, because in fact it's bigger than 1, not less than 1. Okay, moving along to letter C. Okay, so I said when you don't have the same denominators, you have to find the lowest common one. There are choices that the rule is you can technically go 6 times 4, and it will in fact work out. So if I actually made this into 6 times 4 and this one into 4 times 6, which I could do separately, let's do that. 6 times 4 gives you 24. 5 times 4 gives you 20. Subtract. I'm just going to do the next one up here. 4 times 6, that gives you 24. Times 6, that gives you 24. Out of 24, sorry, my brain is very tired at this point. 6 out of 24. The operation is to subtract them. Now we have comparable denominators here, 24 and 24. We can then proceed to subtract. 20 minus 6 is 14. And 24 is the denominator. Oh, my graphics chart just decided to stop. Oh, there it is. Nicely. Now, the problem with this, it is a fraction. It does work out, but this is not fully simplified. Because these things are in fact even, they can be divided by 2, both of them. And this answer would be the proper, fully simplified fraction. We could have avoided that stage if we would have made the lowest common multiple, so we can target that later on by using some simplifications at some point. Okay, so we're going to more so do that with the algebra, pardon me, than we are with the numbers. So I'm pretty sure people are thinking, hey, can we do some of these as some GimKits? No, sorry. If you were in grade 9, I'd say, hey, that would be a great outcome to test. Maybe if I had extra time to do some adding and subtracting fractions, sure. But I don't. We are going to begin with the idea of adding and subtracting single variable rational expressions. Like numbers, the method is going to have, we're going to be able to add the numerator or subtract, provided that we have the exact same denominator value. And the denominator has to be the same variable. Okay, so let's proceed here. Zoom. The first thing we have to ask ourselves, let's look at the denominator. Are they the same? If they are the same, which they are, we can proceed with doing the operation with the numerator. So we're going to have 2x take away x in the numerator, and we have a common denominator. This is going to be 2x take away x. We have 2 x's, take away one of them. That means we have 1x, or just x, over 3. This shall be our final answer for this particular question. Similarly, in letter B, let's proceed over here. We look at the denominator. Oh, 4 is the glitching out. Same as 4. Therefore, we can keep the denominator as 4, and we shall proceed with the operation in the numerator, namely 3x plus another x, which gives us 4x's. divided by 4. Lo and behold, we have numbers that are common, that we can, in fact, reduce, not cancel, but reduce to a 1-to-1 ratio. Therefore, the answer is just x, of all things. Moving along. Yay! What I like about these particular questions, it's nice that they have the same denominator. Okay, therefore, I'm going to draw a very large vinculum, telling me to separate the operations. Vinculum. It's a Latin word to say this is where you begin your operations and consider them differently. Because these are the same, it's a giant 5 on the bottom. Now I can proceed with adding. Adding what? Well, we're going to add the terms 2a minus 3 and 9a plus 1. I'm going to use the like terms first. 2a plus 9a minus 3 plus 1. That means there's more work to be done, because I can see I haven't completely simplified things. Okay, let's circle the groups. Here we go. 2a and 9a make 11a's. Minus 3 plus 1 minus 2, all divided by 5. And since none of these numbers are reducible by each other, this is the final answer. Moving, 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 moving up to D. If you need to pause or ask someone to pause it there, I'm just going to erase the screen. Boom. You can ask to go back on that one. These are the nice ones because they're all numbers. Yay! Very little work to be done. This can be done. If you were to say, hey, can we be tested on this? Perhaps. Perhaps. It's within the reason of checking of these types of operations. Do I have one ready? Absolutely not. Same denominator, which means I have a large vinculum. Boy, when I stare at that, it looks like an angry face. Grr. Now he's sticking your tongue out. Yeah. Okay, so 6 and 6, denominator 6. Now I can proceed to, careful, we have a subtraction here. We have to go 5y minus the 4y. That's being subtracted. Then we have minus 1 minus a 7. Gotta be very careful. This negative applies to both. Sliding over here. I'm just going to group these now and show you what I'm going to get. Yoink. If I have 5y's and I have take away 4y's, I get 1y or just y. Minus 1 minus 7 minus 8. All over 6. None of the numbers reduce. There's like no 2 here or whatever. So this is the final answer. And because we've got a number on the bottom, that's just fine. Zooming out. What do I got here? Oh no. Oh no. These do not have the same bases. I'm still stuck in logs function unit. Different denominators. Oh no. We have to do some work just to make this thing as nice as pleasant as it was above there. Okay, so one tip and trick is to realize what is the lowest common denominator, or namely, which number does 4 and 10 go into? If you were to start writing off the multiples of 4, 8, 12, 16, 20, 10, 20, 30, 40, you'll realize the lowest number doesn't always have to be the 4 times 10. So I'm going to strategize using this, writing the multiples now, if I need to. If I don't know what they are, I can start listing them all out. And when do they converge is one way to do it. Only one. Because off the top of my head right now, there is another way to use powers, but I'm not going to think of that right now. Okay? Excuse me. So, 20 is going to be the lowest common multiple. These are both going to make a fraction out of 20. And there's a subtraction. I'm going to think about each one separately, as in proportional reasoning. How on earth do you get to 4 to 20? What do you got to do? You have to times it by 5. Therefore, we're going to take this term here on top and bottom, times it by 5. 5 times 3x is 15x. How to make 10 to 20? Well, that's times 2. So times 2. 2 times 7x, 14x. Give myself a little bit of space. I know I'm going probably a little bit fast. 15x take away 14x is just 1x. I don't need to write it, but if you feel so comfortable and inclined, please do so. Over 20. And there is the answer we're looking for of the simplified version of the addition, or rather in this case, subtraction. I'm going to just erase that and move my mouse over. That was the other one. That's the easy one. Okay, letter B. Note they are not the same denominator, but again, if I was to strategize, how do I find the lowest common denominator? Namely, I start by writing in the multiples. 3, 6, 9, 12, 15 is the 3. 6, 12, 18, 24. I was just getting a little gung-ho there. Voila. Did he know that? Yes, he did. Don't worry. So, the lowest common denominator is 6. The denominator we're targeting at the bottom of each of these fractions is 6. Yay! Because that one's already done. 4a plus 5 shall be that one. I need to make 3 into a 6 by multiplying it by 2. And now here is where it gets tricky. I got to multiply not only the denominator by 2, but the numerator by 2. This is careful distribution. Are you ready? The arrow is appearing to show you what to multiply by. 2 times 3a gives you 6 a's. Don't forget to go back up to the 2 and say, whoa, 2 times negative 1. We cannot forget, this is a binomial. There are two terms being doubled here. Minus 2. That's really important. A lot of people will miss and put a 1 there. Okay, what are we missing? We're missing this is out of 6, and this does not change, namely plus. Next stage of the writing. I have to redraw not all of it, but the idea is a large vinculum, the fact that now I can combine the terms because they have the same denominator. I'm going to put them in order of the a's first, so 6a plus 4a minus 2 plus 5. And then I'll proceed to the right. And I'll do it in green, that this is a group of things that go together. 6a's and 4a's make 10a's. Minus 2 plus 5, I hope I got it right, plus 3. All right, I'm checking here. 10 and 6 have a common factor of 2, but 3 doesn't. So therefore, that's the fully reduced form. If there's like a 12 here, we would have some extra work to be done. That's what I was just checking to make sure I didn't get it all wrong. Okay. Let me just get rid of that last answer. Off the page. Okay, we've got ourselves the ones that have two different denominators. And in this case, if I was to start writing out my multiples to see what we got, let's just see. I'll just do it over here this time. 8. 8 times 2 is 16. 8 times 3 is 24. Wait a minute, I said 8 times 3. There it is. So if I went 3, 6, 9, 12. They don't have 12. 15, 18, 21, 24. So in fact, the LCD is in fact the 8 times 3. So what I need to do, being very careful, is that this term is going to get multiplied by 3. So is this. I'm going to write it out separately. The over here, this is going to get multiplied by 8 to make 8 times 3. So is the numerator. I'm going to put an 8 in front here. Because it's getting a little clogged up there, I'm going to redraw it from here. 3 bracket, I'll go back to black, 8y minus 3. Shouldn't have done that. Oh well. Okay. My technology glitched out. That's going to be over 24. Minus, we got an 8 bracket. I'm doing the top one over here now. 8 bracket 2y plus 1. All over 24. Now we need to distribute those numbers that we're multiplying. Let's do it very carefully. 3 times 8 happens to be another 24 on the page. But there's 24 y's. Do not forget to go back because we have a binomial. There's an adding thing here that 3 times negative 3 is minus 9 or negative 9. I'm about to pull a fast move on you. Ready? I'm going to make this a negative 8 because it's minus the 8. So I'm going to use a negative 8 to multiply through. Negative 8 times 2. Negative 16y. Then I go back over here. Negative 8 times 1. Negative 8. All over the large vinculum, because now they've got the same denominator of 24. Okay, there's more work to be done. We got to gather and collect like terms. Now they've made some new discoveries here. I got 24 and minus 16. 24 minus 16 happens to be 8y. I should put an equal sign as it goes across. Minus 9 minus 8 is minus 17. Okay, that's prime, so that's good because no distribution of simplification there. And then over 24. Why did I care about that 17? That 17 was nice because they made it in such a way that it can't reduce any of these and that has less work to be done. This is our final answer. Whoops. Okay. Well, it's a little bit better anyways. And we're at 23 minutes. I see on my clock anyways. And let's keep going on from here. Oh, it crashed. Okay, back to that one there. Math 30-2. I was in the rational expressions. I don't know what page I was on. There is that page there. Okay. And last set. Oh, no. Okay. So these ones are getting things that have fractions and non-fractions. Okay. I'll leave that one for later for now. What I'm going to do is I'm going to proceed on to example 5 on page 441. Because now we're going to get to new ideas. Let me now zoom in. New ideas because for the first time, or at least in this particular circumstance, we've got variables on the denominator. All of it had variables in the numerator before. The moment we have variables in the denominator, we have to do the thing where it's missing on the page, restrictions. Because we're dividing by some possible number, we have to start off with NPVs. Right away, these are monomials, one term. That's easy. X cannot be 0. That's simple. That's the starting point. That's actually worth part of your mark right there by saying what X can't be, even in these processes. Or processes. Because they're the same denominator, though, we can proceed to say all of them of these particular fractions can be compared out of X. So we're going to have 2 plus 7. Take away 1. 2 plus 7 happens to be 9. Minus 1 is 8. So this equals 8. And what? I really shouldn't do that and put it on the same line. So therefore I should do this. But 8 is getting divided by X. This is the final simplified expression. So yes, not only we can take expressions and reduce them, we can add and subtract and make reductions as well at some point in the process. Okay, next example. We have got 5a plus 3 divided by 2a plus a minus 6 divided by 2a. Conveniently, same denominators, yay, but before we begin that, we have to consider our restrictions. Boom, boom. Monomials. A cannot be 0. That's the first statement. Because if you're multiplying by A is 0, you're divided by A, or 0. Can't happen. Okay, since we have the same denominators, we can proceed thusly over to A, 5A. I'm going to add the next one, plus A, plus 3, and then minus 6. Okay, now we have to gather like terms. Green it shall be. We have 5a plus a gives us 6a's. Oops, glitching out here. 6a. Plus 3 minus 6 minus 3. Uh-oh. Thankfully, it's not a 3 here. Make less work. 2a. 3 doesn't divide by 2, so that's the rest there. The statement would look like this. 6a minus 3 over 2a, where a cannot be 0. That's the way the textbook is going to say your answers, by the way. They leave the NPVs until the very end. Okay? Next. Uh-oh. We have ourselves a binomial on the bottom. Namely, the denominator is a binomial, which is very different. We have to go back to the very beginning of ideas when we had these binomials. We have to have the situation that 3y minus 1 cannot be 0 for both of them. Thankfully, it's just the same for both. Add 1, 3y cannot be 1. Divide by 3, divide by 3. Our restriction for all our work shall be y cannot be 1/3. That's just simply the restriction. Yes, you may have been able to jump right that mentally. That's a-okay. Now, we have to see we have the same denominator, so we can proceed with the idea that we have 3y minus 1 on the denominator. We've got 3y minus 1. It appears that we have the same thing, top and bottom. Is it 0? No. It's a 1-to-1 ratio. This answer is 1, provided the y still can't be 1/3. Weird, hey? Okay. This is a nice question. And I think it's as far as we're going to be going here so far in my mind anyways at this point, because we're at, what, 29 minutes? Oh, actually, we have a little bit more. Okay, I'm going to erase that. I probably shouldn't. All right. Next example, example 6. It says, prove, or it doesn't even say prove, but show, demonstrate that this works out to this. Just this expression. So you already have the answer or the target to what we're trying to hit right here. That's what everything works out. Plus, we have the NPV. So that's done for us, so I don't have to do that one. Can you see that? Can't be -3? Probably. It's pretty obvious. Now, got to get it to work to 2. Oh boy. This is going to involve a little bit more work. Same denominator first. That's a nice beginning. So, therefore, it appears that we can proceed by writing it out everything as x plus 3. Indeed, we can. So we will start gathering like terms. We have 4x. We have a subtract 2x. I have 10. And then minus the 4. Minus the 4. Let's proceed. Gathering the like terms. 4x, take away 2x, is 2x. Plus 10 minus 4 is plus 6 over x plus 3. Now it's kind of tell us this isn't 2. But what is it? Well, it's the idea of what is common to both these two terms, namely factoring. 2x and 6 have a 2 common. We can divide them both out by 2. Divide out by 2. We get 2 bracket x plus 3 over x plus 3. That's the key about recognizing sometimes we mess up, or rather muck up the top and add and subtract a few things, and it becomes something brand new, which could be factorable, which may have the answer in the bottom of the numerator as part of one of the factors. Now, are we done? Nope, because what we have to do is make this the 1-to-1 ratio. 1, 1, therefore 2. Now it's 2, and cannot be x -3. Notice the numerator of the answer had a factor in common right here with the denominator. This results in further reduction, which is a more simplified answer. Full credit means you find all the full reductions. We must always check to see if our answers are fully reduced. This is a very difficult task if you don't know when you're working on questions that don't have answers. Thankfully, all your homework has answers to check to see if you've got it down to the most reduced form. Quizzes do not, although GimKits may have that. I think I glitched it out. I sure did. Okay, the document was just there. I think my graphic card's getting pretty tired here. And over here, open that document up. All right. Is this it? Yep. Adding and subtracting different monomial denominators. Previous? Yeah. Okay. So, last set of examples to try in which we're going to add, we're going to add different monomials, just monomials today, so that we can make simplified expressions. Okay, so I look at the numbers first. I have 3p, 7. 7 and 3, well, they're not multiples of each other, but if I take this 3 and I multiply it by 7, I'll get 21p. And if I take this 7 and multiply it by 3, I'll get 21p. Therefore, that will be the same denominator. That tells me what I need to do, both in the numerator and denominator. 7 times 5, 35. Over 7 times 3, 21p. Plus 2 times 3, 6 over 21p. 35 plus 6 happens to be 41 all over 21p. 41 happens to be a prime number, and therefore this is not reducible. It's not one of the multiples of p. There's the final answer, except I forgot something. What did I forget? There. Let me just erase this. Yes, I got quiet just to see if people actually... Oh, no. There we go. Back up here. Okay, B. Uh-oh. Now it gets a little trickier because now we got totally different things. One's with letters, one's with numbers only. Well, rule of thumb is we need to have everything that's going to be a product of all these terms. So basically, one thing to do is we have LCD. Best choice is going to be 3y times 5. That's one of the ways to get the LCD, or at least one of the things. Okay, this has a 3y. That means I should multiply this by 5. This has a 1 and 5. That's going to be 5. This needs a 3y. So you got 5 times 3y. It's glitching out on me. Oh, 3y times this by 3y. And we're going to get 6 plus 3y, or 6 times 3y, 18. My graphics card's getting pretty tired. Okay, and therefore, oops, undo that one. 18y. Now we have the same denominator. 5 times 3 is 15 y's. We have 5 plus 18y. Normally, you'd probably see the 18 first, but we're just in that sequence, so we know 5 plus 18y. 5 and 15 have a common 5, but that doesn't have a common 5 here, so this is the final answer. Oh, wait. We had a variable in the denominator. It's a monomial, so it's fairly easy. Y can't be 0. Scooting along here. Okay, so technically you could in fact make this just the multiplying of each other here. 6x times 3x. You could do that. Not necessarily advised. The multiples of 3 can go into 6. Namely, I can make a 3x into 6x simply by multiplying this by 2. That's already a 6x because I go 2 times 3, I get 6x. That's already a 6x, so there's the LCD. But the problem is, after what I do to the denominator, I must do 2, if the graphic card will handle it, the numerator, times this by 2. So I'm going to need to write this out below. Need to do some erasing here. That's much better. Get rid of all that other stuff. Could have erased the board, but it keeps glitching to the top. I'm going to start this expression as the first one, the first term expression, rational expression, doesn't change because it already has the proper denominator, so it's already comparable. So 2x minus 5 over 6x minus, here we go, I'm about to do the distribution, 2 times 3x happens to be 6x. In fact, what I should do is put the 2 in front and make it a negative 2, because that's what's going to happen. Negative. Negative 2 times negative 2, positive 4. These things are getting really tricky, aren't they? Perhaps I should go back and explain that really quick. All right, because some people are like, what just happened? To recap, we're trying to make this 3x into a 6x. I want to multiply this by 2. I put it on the right-hand side. I should put it on the left. Now, if I make it a 2 on the front of this group, I can apply the negative to this 2 and distribute like I did that question before where I had a negative 8, I think it was. And so now I can like negative 2 times 3x, negative 6x, negative 2 times negative 2, positive 4. When I do this, I can just go like this. Same vinculum now. Ooh, look at that. I got to make sure I can collect my like terms properly though here. 2x minus 6x. Ew, That's not pretty. It's negative. Negative 4x on the numerator. Minus 5x plus 4 is minus 1 all over 6x. Of course, now I'm not done. I forgot one thing yet again. I didn't forget. I like to just leave it to the end, but I shouldn't. X cannot be 0. Boy, oh boy. Okay, last one. Thank you for enduring this time. I appreciate it if you're still here mentally. Some people may have tapped out, but I do appreciate it. So this time we've got different variables, or rather variables at different degrees, a and a squared. We're just going to do this time. Our LCD is going to need a 2, an a 5, and not only an a squared. Okay, I don't need the a though itself. I already have that built in. So it's going to be a 2. It needs an a squared because that's the highest degree. That's what it needs. And then it needs a 5. You might think, why do I need an a? Well, I've already got an a in the a squared. So what you do, by general rule of thumb, when you have variables of different degrees, all you need essentially is the highest degree to add. So in each of the terms, I need to make 2a squared times 5. I have in this first one times 5 here is all I need to make that LCD. So what I'm going to do is I'm going to make that times it by 5. Let's do that distribution right now. 5 times a, I'll put way down here, 5a. 5 times 7 plus 35. All over. What's it all over? Well, I found my LCD. 2 times a squared times 5. We can combine the numbers, by the way. Let's just make that a little happen here. 2 times 5 is 10. A squared is the denominator. We're going to subtract. We haven't done anything here with yes yet. 5a. I need a 2. And I need an a squared, so I have to multiply it by another a. Boy, oh, that's really weird. Glitching out. Back one more. There we go. I need an a. So what I need is 2a to make that happen. So I got to multiply this by 2a. Minus 3 times 2a is minus 6a. Or minus 6a. We have the same denominator of 10a squared. We can proceed by grouping like terms. 5a minus 6a, unfortunately, is negative a, plus the 35, all over 10a squared. There it is in all its splendor. Of course, we need to consider the fact that because we have a monomial, the variable a in both terms, a cannot be 0, stating the restriction. Okay, it is now time to get to work of practice. Let's see. What should you be able to model, or rather replicate in your practice here? Whoops, wrong button there. Well, let's see. Do you want to practice adding and subtracting basic numbers? That's your choice. Okay? If you want to, that's optional. Okay? That's not necessarily Math 30 level, but it's good back review. When you have ones with monomials on the numerator, absolutely. Perhaps you should do all of these 4 on question 2. So question 2, number 2, all of them. Zoom in here so you can see what I'm talking about. Alrighty, question 3 says to simplify. Pick 2. Pick any 2 you want. I don't need you to do all of them because they're just simply the same process with just numbers. At some point, you're going to have to do 3 terms, so maybe you want to pick C. Question 4 has a lot to practice here. It has got some 3 terms. It's got some 2 terms. There's 6 of them there. I would recommend you pick 2 again. Pick any 2 you wish. If you think you need more practice because you're not getting them, pick 3. Question 5, we're going to leave that one for now. I don't like the ones that have non-denominators. Question 6, whoops, previous page. Don't skip too fast. Question 6. These are the nice easy ones. Yes, you should be practicing all of question 6. And honestly, you should pick 3. As opposed to like doing, pick 3. Okay, 7. You got A, B, C, D. Pick 2 of A, B, C, D. Question 8. Different denominators. This was like the last example. There's 3 of them. I suggest you get at least familiar with one of them. Just pick one of those. A, B, or C. There's some students' work. Yes, you should practice checking to see what they did. That'd be question 9. Whoops, that's zoomed out. It says, here's some students' work. You got to be able to figure out what steps they made. Identify and indicate the steps. Yes, standard of excellence to actually correct the steps, by the way. These are GIM-kittable at some point, by the way. When you want to see what a GIM-kit's going to look like, that's what I would choose, one of those types of questions. And that shall suffice in terms of erase that. Okay, you have the lesson. You have hopefully something to refer to if you followed along on the examples, and therefore you can now spend the rest of the class, which should be about 35 minutes or so, working. Thank you, and I hope to see you soon.